Welcome to u-Substitution and integration by parts together. So just a note, not all integrals can be solved with just using one technique. Some integrals require using multiple techniques. To solve. So for example, let's go ahead and evaluate the indefinite integral, which is the integral of sine of the natural log of x dx. So we have a composition with an outside function of sine of x and an inside function of natural log of x. And so this lends itself to u-Substitution. We usually pick our inside function as our u. So we will go ahead and set u to be equal to the natural log of x. Then that means that our du is 1 over x dx, or dx is x times du. Now, if we look back at the original problem, there is no 1 over x dx, so we would need to go to x du. So we have the integral of sine of natural log of x dx is equal to the integral of sine of u times x du. But we are still not rid of the x's here. So at this point, note that if u equals the natural log of x, then we have that x is e to the u. And so this becomes our integral is the integral of sine of u times e to the u du. At this point, we can run integration by parts. So now we have a product of completely unrelated functions. At least when it comes to integrals and derivatives. And so that lends itself towards integration by parts. So I'm actually going to go through and rename our variables, not with u, since we already do u and dv, and that will get confusing. So let's rename u with, let's do s. So we are looking at the integral of sine of s times e to the s ds. The reason I did this is because our integration by parts, I use u and dv. So let's do our u and dv. Doesn't matter which we pick as which. I'm going to pick sine as my u. So sine of s is my u. e to the s ds is my dv. We differentiate on the left, integrate on the right. Sine of s becomes cosine of s. Sorry, these should be derivative with respect to s here. So sine goes to cosine s, e to the s just stays e to the s. Cosine s then would go to a negative sine s. E to the s again goes to e to the s. Our bottom row product matches our top row. This is a cyclical integration problem. So we do our plus the first diagonal minus the second, and then we'll do plus the integral of the bottom row. So we are looking at the integral of sine of s times e to the s ds is equal to sine of s times e to the s minus cosine of s times e to the s plus the integral of negative sine of s e to the s ds. If we set a equal to the integral of sine of s e to the s ds, then we are looking at a equals sine of s e to the s minus cosine of s e to the s minus a, or 2a equals sine of s e to the s minus cosine of s e to the s. And we therefore get that a is equal to 1/2 e to the s sine of s minus e to the s cosine s. That 1/2 multiplying the entire thing. At this point, we will plug back in the fact that s is equal to u, which was equal to the natural log of x. So we have the integral of sine of x, sorry, sine of natural log of x dx is equal to 1/2 times e to the natural log of x times sine of natural log of x. Let me shift this whole thing down a row. There we go. Still being multiplied by 1/2, we then had minus e to the natural log of x, cosine of natural log of x. Then we have our plus c. Of course, e to the natural log of x is simply x. So we wind up with this integral is equal to 1/2, then in parentheses, x times sine of natural log of x minus x times cosine of natural log of x, and the parentheses, and then plus c. So we can kind of play around and do some odd tricks with u-substitution before we then run integration by parts. All right, that's it for integration by parts. In the next videos, we will look at various possible trig integrals and how we can solve them.